Alright, this is the next video. This should be the third video, excuse me, in the basics of multiplication. You saw the basics video, and then you have watched the, excuse me, multiplying by 1, and then you also saw multiplying by 2. So just a quick review about the commutative property of multiplication. The commutative property of multiplication tells me that it doesn't matter the order of my factors in a multiplication equation, my product is always going to be the same. So if I have 7 times 9 equals 63, then I can have 9 times 7 equals 63. I can switch my factors around, but my product always stays the same. So this is very important to remember. Today we're going to talk about 2 more multiplication tables. The first are the tens. Tens are totally terrific. Tens are easy. We did ones. Ones were easy. Twos are easy. Tens are the next easiest one in the bunch here, because when you multiply by 10, all you're going to do is put a 0 after the other factor. So in your multiplication equation, let's say I have 7 times 10. 10 is one of my factors, 7 is the other, so I'm multiplying by 10. All I'm going to do is put a 0 after that 7, so I get 70. I can show my commutative property. 7 times 10 is 70, but then I also have 10 times 7 is 70. So I've reversed the order of my factors, but I still have this same product. How about 10 times 4 is 40? Change the order of my factors. I'm still going to get 4 times 10 is 40. And all I've had to do is add this 0 after this other factor. Okay? What about for bigger numbers? Does it work for bigger numbers? Absolutely. All I'm going to do is add that 0 after the other factor. So if I'm multiplying by 10, my other factor is 23. My rule tells me I put a 0 after the other factor. So I've written 23, and I've just added that 0. So 23 times 10 is 230. Commutative property tells me I can switch the order of these factors and show 10 times 23 is 230, because all I have to do, this is my other factor, and all I have to do is put a 0 after it when I multiply by 10. Now, when you start multiplying 10 times numbers that have zeros in them, if my other factor has zeros, you always have to be careful and make sure you count your zeros. What if I want to show 100 times 10? I have to do the same thing. I'm going to take this other factor, I'm going to write it here, and then I'm going to add the 0 at the end. So 100 times 10 is 1,000. And over on this side, I can change the order of my factors. My product is going to be the same. 10 times 100, here's my other factor. It's there, and all I'm going to do is add the 0. So when you multiply by 10, all you have to do is put that 1 0 after the other factor. Okay, so 5s are easy. So we've got 1s, we've got 2s, 10s are simple. We've got 1s, we've got 2s, we have 10s. Let's move on to one we might have to work on a little bit, and that's multiplying by 3. Okay, no tricks, no gimmicks, no secrets for 3. When you multiply 3 by 3, you're just going to have to skip count by 3 and begin to memorize your facts. We skip count by 3, 3, 6, 9, 12, 15, 18. Then it goes on and on. And you're just going to have to memorize these facts, but as you're learning them, you skip count that many times. So if I'm going to do 3 times 6, I'm going to skip count 6 times. 1, 2, 3, 4, 5, 6. And I'll get 18. Commutative property tells me I can switch the order of my factors, and my product is going to be the same. So 6 times 3 equals 18. If I'm going to skip count 3 times 9, I'll skip count 9 times, and I'll get to 27. There's my product. I can switch the order of these factors, and I know that 9 times 3 equals 27. So this may be one you have to work on a little bit to memorize your 3s, but in the beginning, as you're learning them, you can just skip count by 3s. So where does that put us on our chart? Well, let's go and look. We've memorized all of our tens. Remember, tens are totally terrific and really simple because all you have to do is add the 0. So I can come down to my 10th row, and I've already learned the first two, 10 times 1, 10 times 2. So I can now color in the rest of my tens going across, because those are pretty simple. I don't even have to work at them really hard. So I'm just going to add that 0 behind the other factor. So 10 times 11 would be 110. 10 times 12 would be 120. And 10 times 10 is 100. We all know that. Okay? But if I've learned my 10th row, then doesn't it make sense that I've also learned my 10th column? So if I go over to my 10th column, I can also color this in. And I've learned 3s, 4s, 5, 6, 7s, 8s, 9s. I've learned some of my 11s and some of my 12s. So which one's really hard? 7s are hard, right? 7s are hard. I've already learned 1, 2, 3 of my 7 facts. So that doesn't leave a whole lot for me to have to remember. So I can color in, I've learned all of these 10s and all of these 10s. Once you memorize your 3s and you know them fast enough that you're not having to skip count every time, you can come down, and that means you've memorized all of the 3s going across. So that takes care of my 3rd row. My nice coloring. But if I memorize my 3rd row, haven't I also memorized my 3rd column? Sure I have. Because the commutative property tells me that 3 times 4 is the same as 4 times 3. So I've already learned some of my 4s. Commutative property tells me if I know 3 times 5, well, I know 5 times 3. If I know 3 times 6, holy moly, I've memorized some of my 6s. I know 6 times 3. 3 times 7, I've memorized my 7s. I've memorized some of my 8s. I know some of my 9s. Of course, we know our 10s. I've got some of my 11s, and I'm taking care of those 12s. So if I look at this chart, I can see how much I've colored in, and then I can see I only have that many more equations that I need to memorize. So going about it this way, I've learned my 1s, my 2s, I know my 10s. I'm going to work on my 3s now. I'm really taking care of business and getting these memorized.